Hey guys, you're looking at the tuning condenser here for that Silvertone 1704 radio. I gave it a nice bath in Evapo-Rust for a good 2+ days, followed by at least 10 full cycles in the ultrasonic cleaner. And you'll see that in the picture-in-picture there, just a snippet of that process. And about halfway through those cycles, I took this outside, threw the water hose to it, rinsed it off, brought it back in, changed out my washing solution there, and ran it through for another 5 cycles or so. Once I was complete, back outside, fresh water again, and then the drying process itself. But it turned out really well. I see a few areas I can touch up. But when we left off, this thing was seized up, and you can see now I can move it. So that's a good thing. But the only thing that's really holding this back, best I can tell, is this one bent plate right here on the outside that we need to correct. But before we do, I thought it would be a great segue. I've covered this in some other videos, but let's talk real quick about the tuning condenser itself. This piece that rotates is the rotor, and the stationary plates here and here and here are referred to as the stator. And we'll reference this on the schematic as well, because it used to be very confusing for me. The rotor here is attached to the frame, and we'll check for continuity between the rotor and the frame. And then the stator, these locations here that you can see, they actually tie back to your lugs here, your solder 2 lugs. And you can see this is a 3-section or 3-gang tuning condenser, and it has some little trimmers on the top as well for fine-tuning the capacitance. This solder connection here should connect to this solder connection, and of course it's isolated from each section. Same here, this section here is the same as here. We'll look at this closer on the schematic when we wire it up and retouch on the stator and rotor and the symbol that was typically used to distinguish between the two. You can see I've got my voltmeter or VOM here. Let's go over into the continuity mode and just check what we talked about. We'll look for any type of DC resistance or continuity here between this point being the stator and the rotor, and we'll do it for each section. When we get to this section, we should show a continuity or a short due to that plate rubbing that we need to correct. Okay, nothing there in the position that we're in actually. To test this thoroughly, you would need to rotate it through the entire movement, being closed to open. And we're good there. And this should be our trouble spot. And it is. Now another thing too, I mentioned the stator ties to the lugs here. Let me just tie into the lug here on the bottom. That's the solder 2 location, and go back here, and you see I have nothing, and I go here back to the stator itself, and you see we have continuity. Same thing now if I come above and check here, I should have continuity here, but nothing at these other locations. So I hope that makes a little sense. For a while they threw me, especially looking at the schematic symbol itself. Let's fix this plate here. We're going to just have to get in here and bend it. And then we'll rotate this through and make certain that the short has been removed from this section, and make sure we don't have any additional issues here in either one of the other two sections. The spacing here on the capacitor itself can be just a few thousandths of an inch. So you can use thin plastic, get creative. I've even used pieces of sandpaper before. To start this, let me see if I can get down in here and just bend this over. Somebody did the number on it, that's for sure. Okay, I'm just eyeballing it here. I can still see this back section here is not formed correctly, so let me see if I can move it ever so slightly. I may have enough separation now to remove the short. Well, possibly. Looks like back in here I'm still rubbing or making contact. The rotor is with the stator. See that this plate here on the rotor section, which moves, was shorted or mashed up against each other, and when it was rotated through, it would short against the stator connection in this particular section only. The other two sections checked just fine. So let me show you how I actually made the measurement, just to make sure that we're clear. And of course I'm not going to bend this back in to create another short, because it took 10-15 minutes or so just to work out all the kinks and get this section here free, where it would not short through its entire rotation, that being completely open and closed. And just go to the frame itself. You can see my connection here. Nothing, nothing, and nothing, and that's good news. Now again, I'm not rotating the tuning condenser. We'll need to do that to make sure that that short's gone. But to my point, you can see the frame and the rotor are attached, because we have continuity there. Let's go back to this section here that was shorted. So I'm going from the stator itself here with the lug back to the rotor, which is attached to the frame. And let's rotate this through. And the short was occurring from about right here to the closed position. And you can see we're good now. So I just wanted to demonstrate that. We'll spend more time in the video here in just a bit when we remount this and talk about how to identify these three sections on the schematic. I want to show you guys the last IF coil that I've been working on, and then we'll get it remounted into the chassis here. Now look at the schematic first. L2 is the coil that we're working with here. It's one of the IF coils, and you can see will be the first IF, this being the second IF. The ugly L2 coil, the IF coil, and you can see it looks better. You guys recall that had watched the prior videos, this is the one that was had a big chunk of beeswax on it. Had the leads that were leaving the capacitor box, those 0.1 microfarad caps, encapsulated here to the coil. So very strange. I probably got a pound of beeswax out of this radio. Of course, just kidding, but there was a lot of beeswax for some reason inside the chassis and around different parts, including the tube shield. Anyway, you can see that I used a sharp razor. I was able to remove the existing dielectric with caution. These are the original leads. And I went back with color coding, this being my B+, just going back to my plate, a ground, and a grid. So this will make more sense once we get it tied in and you guys refer back to the schematic with me. I did check, and DC resistance is the same. I have not repeated my inductance measurements, but I wouldn't feel that they've changed. The cool thing is, if I would have got the leads mixed up, or if I do, the coils are identical. They read practically the same DC resistance and inductance. Alright, let's get L2 back into the chassis. Before we mount it, pretty cool too. Isn't it amazing how simple things were back in the day, but how well they worked? Piece of wood used as a form factor, nothing more than a dowel and a screw to hold the two coils in place. My mounting location is right here. There's a hole. I'm going to have my hands here in front of the camera, so let me go ahead and get this mounted. I've got that mounted back in there now, and I think I have it positioned the way I want it. Let's reference the schematic and look at our tie-in points here for the primary and secondary of this IF coil. This should be relatively simple. You can see point 1, point 2, that being the primary side of the coil. It attaches itself over here to C4. So that's all we need to do. Now, number 1 connection is my red lead, or my B+, and the one that I color-coded blue, the plate, will go back to the plate of the 6A7. But what we want to do is hook up the blue lead here back to the plate of the 6A7. And that resides here, pin number 2, and it's this red lead that comes back across the existing lead and ties in right here. Now, I just checked, so I'm sure I cut just a little bit of the wire off. I'm a little short there with my lead length, but no big deal. I want to take some pushback wire and form a coil and extend this by maybe an inch or so. Here's what I've elected to do. You can see the cloth pushback wire. I'm going to go ahead and use my small screwdriver here, leverage the coil technique. I'll cut this back here. We'll slip this on, put some heat shrink on, and then solder it back in. That should work. You can see the red lead off the coil, which is my tie-in point number 1, here being the primary of the coil. It's long enough to make it over here, but I don't like the routing here of the conductor. So let me extend it also, maybe 1.5 inches or so, and see if we can kind of tuck these back in here closer to the existing caps. I've got everything tied in there to C4, Charlie 4, and extending those leads was the right choice. You can see I've got everything tucked in back here on the underneath side of the caps. These two here may not be as problematic, because I think they go right here to this cap. I've made the grid connection here, that yellow wire that you can see connecting back to the grid wire here. And on the other side of capacitor C5, the black lead, but nothing else is soldered up at this point to this capacitor. Let's go back to the schematic. I haven't highlighted this yet, but connection point 1 and 2 are complete here on this primary side. And I just made number 3, that yellow lead that ties into the grid right here of the 6B7. And now we need to tie in a jumper between R3 or Charlie 6 at 0.1 microfarad cap here back to the other side of C5 where I have the black lead attached. Let's go back to the chassis and look at R3. R3 resides here, a 500K resistor. So which end do we use? You guys recall the end we're looking for has the 0.1 microfarad cap, and that's actually right here. You may not be able to see it, but it's one of my yellow leads that you can see right here possibly that go down to the capacitor bank. So let me unsolder maybe just a little bit of an area right here. We'll get a small jumper made and come from this point right back over here to this side of the cap, and we'll be done with this particular coil. Okay, I think that turned out pretty neat. A little small jumper here from the resistor I mentioned, R3 back over here to this side of the cap along with the black lead, and of course the grid wire back with the yellow. And that completes this particular coil here, L2. Let me grab the schematic, just double check everything here, get everything shaded in yellow, and let's move along to the next tie-in point. Alright, L2 here is complete. I know I still need to tie in the B plus here from C19. I don't think I've done that, and it may also be a great opportunity to take a look at some of the remaining wires that I had cut loose from the tube sockets, and let's see what we got left with nothing hooked to them, and find out why. The first mystery wire, you can see this one here, and I don't have it tied into anything, but just looking at it, it looks like it routes back over here to the 77 tube, and after some more testing here with my meter, that is the case. And here I've got continuity here. And looking at the pin number, this is the 77 tube, I think, as I noted. Pin number 1, 2, and 3. Pin number 3 is grid number 2. Let's look at that on the schematic. and it will be that middle grid. And you can see it comes down. I've already got it highlighted yellow. It ties into R11, R12, and C14. So what I believe that lead to be is one of the old leads running over to the capacitor bank. As you'll see, my connection point for the capacitor back to grid number 2 is made here on the resistor board, that yellow lead. And I already have another small jumper here running from the grid back up. So I'm going to try to clip this off. And of course we've got it noted. If that comes back and that's problematic, we'll do some reverse engineering and find out why. This next conductor here, this red lead, I can tell it attaches here to the type 43 tube socket. And just looking here, pin number 1, 2, and 3 here. So pin number 3, I believe, is also grid 2. Let me grab the schematic here. Alright, referencing the schematic here for the type 43, grid number 2 would be here closest to the plate. And you can see it runs down. Of course, we still do have a tie-in location here listed as yellow back to the output transformer that feeds the speaker. But you can see that runs down, runs across, maybe it's this missing link right here on my B+. Let's check continuity between the plus side of C19 or the plus side of C21 back to grid number 2 and see if we have continuity. I'm going to just leave the meter attached here to grid number 2 on the 43 tube. And I'm going to go over here to the 10 microfarad cap. You guys recall the schematic calls for 8s. I bumped them up to 10s. This is that standalone capacitor that we were looking at out to the right. Of course, negative this direction, positive back this direction. So let's just check here. And you can see we have no continuity between the two. Go back to the schematic. You can see where I was testing again. Referenced as C21 on the schematic. Let me go ahead and check between that red wire that goes back to grid number 2 on the 43 and make sure that we've got continuity between that lead and the other B+ locations, that being the plates of the remaining tubes. Let's start out by looking at the plate of 6A7. Now of course there'll be a little bit of resistance due to the coil that we went through, in addition to the oscillator coil. Let me go to the plate of 6A7. We'll see what we've got. The 6A7 resides here, and pin number 2 is what I'm looking for. And we just flip it over and look at DC resistance. And that's the coils that I'm going through. But I do have continuity at that point. So what that tells us is my B plus, at least to this point, back over and up is good. Let me go ahead and just double check myself and make certain that we're good here on the 6B7 as well. The 6B7 resides right here, and it's also pin 2 for the plate. So let me check right here. I'll see what we've got. Okay, we're good there as well. Alright, let's do the same exercise here for the 77 tube, the plate. You can see I don't have a direct link back to the B plus rail. So I've got a 400 ohm, excuse me, a 400,000 ohm and a 50,000 ohm resistor. So let's look at DC resistance between the plate and grid number 2 on the 43 and see if we have close to 450,000 ohms. And hopefully you guys can see that. We're right where we should be. So based on what we just tested, I really just need to tie in that red lead off of 43, grid number 2, back over to the connection point of C21 and C19, and that should complete this B plus gap that we have right now. And the B plus should be complete now. And what I'm going to do is, I don't have a red marker, I'm going to just highlight this in orange, put through here so I can remember where I made my tie-in. Okay folks, I think that's it for today. You'll see I have the speaker tie-in point here. I've got to redo those leads protruding from the field coil itself, as well as the output transformer. Then we can get it remounted, but I'll probably save the speaker for last. When we pick back up, we'll go ahead and get the tuning condenser back on the top side of the chassis, as well as this next coil, which would be the last coil, thank goodness, the pre-selector coil. And I think that's it. I appreciate you guys following along. Take care.